Hello everyone, welcome to the Mathematics in my channel. In this video, we are going to solve this interesting elliptic integral from 0 to 1, square root of 2 minus x square over 1 minus x square dx. And we know this is equal to gamma square of 1 over 4 times the square root of 2 pi plus pi times the square root of 2 pi over gamma square of 1 over 4 is equal to e of I. Here e we know complete elliptic integral of the second kind. Well, how to begin? Okay, first we can take a substitution. If we take x is equal to cosine of u, then we know differentiation dx is equal to minus sine of u du. Okay, then we can plug in. Now we know after taking the substitution, limit will be pi over 2 to 0. Then here square root of 2 minus x, we know cosine of u, so cosine square of u over 1 minus cosine square of u times dx, we know minus sine of u times du. Okay, then we can change this limit 0 to pi over 2. When we change the limit, this minus sign get cancelled. And here we have 2 minus cosine square of u, we know 1 plus 1 minus cosine square of u, we know sine square of u over again 1 minus cosine square of u, we know sine square of u times sine of u times du. Then we know square root of sine square of u, sine of u, and this sine of u get cancelled. So we have integral from 0 to pi over 2 square root of 1 plus sine square of u times du. Well, then recall the complete elliptic integral of the second kind. We know the formula e of k is equal to integral from 0 to pi over 2 square root of 1 minus k square sine square of theta d theta. Then if we take e of I instead of k, now we are going to plug in I. We know 0 to pi over 2. Here 1 minus k square. K we know now I square. We know minus 1. So here we have minus plus sine square of theta d theta. Okay, then we know our integral is equal to e of I. So here e of I. Now we know e of I is equal to integral from 0 to pi over 2 square root of 1 plus sine square of u times du. Okay, now we have to evaluate this integral. Therefore, I am going to take another substitution. Sine of u is equal to x. Then we can differentiate cosine of u du is equal to dx. Okay, let's plug in. Now we should change the limit. Limit we know now 0 to sine of phi over 2. Here 1 times here square root of 1 plus sine square of u, we know x square times du we know dx over cosine of u. Okay, now cosine of u we know 1 minus square root of 1 minus x square. So we have 1 plus x square over square root of 1 minus x square times dx. Well, then both numerator and denominator I am going to multiply by the square root of 1 plus x square. So we have here we know square root sign get cancelled. So 1 plus x square over the square root of 1 minus x square, 1 plus x square, difference of 2 squared. So we can write 1 minus x to the 4th power dx. Okay, then we can write this integral into two different integrals by dividing the square root of 1 minus x square. So we have dx over the square root of 1 minus x to the 4th power plus integral from 0 to 1 x square dx over the square root of 1 minus x to the 4th power. Well, then for both integrals, I am going to take another substitution. X to the fourth power is equal to t. Then if we differentiate, 4 times x cube dx is equal to dt. Then if you isolate the dx, we know dx is equal to dt over 4 times x to the third power. Okay, let us plug in. So here now we know limit also 0 to 1. Then dx we know dt over 4 times x to the third power. X we know here x we know t to the 1 over 4. So here we have t to the 3 over 4 times here square root of 1 minus t, square root of 1 minus t, then plus here limit also we know 0 to 1. Now x square dx, x square dx is equal to, we know x square dx is equal to dt over 4 times x. So we have dt over 4 times, now x we know t to the 1 over 4. So t to the 1 over 4 is square root of 1 minus t. Okay, then we can also write this is equal to integral from 0 to 1. Here 1 over 4 is a constant, so 1 over 4 times integral from 0 to 1 t to the minus 3 over 4 times 1 minus t to the minus 1 half dt plus here 1 over 4 also is constant, 0 to 1 t to the minus 1 over 4 times 1 minus t raised to the minus 1 half dt. Well, then let's call the beta function. We know beta of xy is equal to integral from 0 to 1 t to the x minus 1 times 1 minus t to the y minus 1 dt. Now we can find the x and y. So we know minus 3 over 4 is equal to x minus 1. So minus 3 over 4 is equal to x minus 1, and if you isolate the x, we know x is equal to 1 over 4. Then minus 1 half is equal to y minus 1. Therefore y is equal to 1 half. Now for this integral, we know minus 1 over 4 is equal to x minus 1. Then x is equal to 3 over 4. Also minus 1 half is equal to y minus 1. Then y is equal to 1 half. Therefore our integral we can write by using beta function. This is equal to 1 over 4 beta of 1 over 4 comma 1 half plus 1 over 4 times beta of 3 over 4 comma 1 half. Now we know the relation between beta function and gamma function. So 1 over 4 gamma of 1 over 4 times gamma of 1 half over gamma of 1 over 4 plus 1 over 2 plus 1 over 4 times gamma of 3 over 4 gamma of 1 half over gamma of 3 over 4 plus 1 half. Well, then we know gamma of 1 half is equal to square root of pi. So square root of pi over 4 gamma of 1 over 4 over here we know gamma of 3 over 4 plus 1 over 4 times again gamma of 1 half we know square root of pi. So square root of pi over 4 times gamma of 3 over 4 over gamma of here we have 5 over 4. Okay, then I am going to multiply both numerator and denominator by gamma of 1 over 4. So we have square root of 5 over 4. Here gamma square of 1 over 4 over gamma of 1 over 4 times gamma of 3 over 4 we can write gamma of 1 minus 1 over 4. Then here plus square root of pi over 4. Then again I am going to multiply both numerator and denominator by gamma of 1 over 4. So gamma of 1 over 4. Gamma of 3 over 4, we can write gamma of 1 minus 1 over 4 over here gamma of 5 over 4. We know gamma of 5 over 4 is equal to gamma of 1 plus 1 over 4. So this is equal to 1 over 4 times gamma of 1 over 4. So 1 over 4 times gamma of 1 over 4, and also we know we multiply by gamma of 1 over 4. So here again gamma of 1 over 4. Okay, then we know the Euler's reflection formula. Gamma of n times gamma of 1 minus n is equal to pi over sine of pi n. So we can write here square root of pi over 4 times gamma square of 1 over 4 over here we know pi over sine of pi over 4. Then here again square root of 5 over 4. Here this 4 get cancelled. So square root of pi times this part we can apply reflection formula. So here pi over sine of pi over 4 times gamma square of 1 over 4. Okay, then we know sine of 5 over 4 1 over square root of 2. So we have gamma square of 1 over 4 square root of pi get cancelled. So 4 times square root of 2 times pi plus here sine of 5 over 4 1 over square root of 2. So pi times square root of 2 pi over gamma square of 1 over 4. We know this is e of I, and e of I is equal to our integral. Okay, this is the answer for this integral. If you like this type of videos, please subscribe this channel. Thank you for watching.